Uh-oh. Sorry, I clicked on the wrong page. All right, so the small one. So you have this, and we're going to compare it with the largest triangle because the 10 and the A correspond, and the 4 and the 2 root 29 correspond. So your proportion would be what?
Would it be a over 10 or equals 4 over 2 root 29?
Yes. That looks like a 9, but it's supposed to be an A. Sorry. And then you cross multiply, and that would get you the altitude. So I'm going to do it on the screen, but you try it, and then we'll compare. Do we match?
Yep.
Good. So 43 is the same, where you draw your 3 little triangles and label the parts.
Okay.
43 is also a right triangle. So
Yeah.
that's why this little 3 triangle thing works, is if it's a right triangle, you can do that. Because when you draw the altitude in a right triangle, from that right angle to the hypotenuse, it makes 3 similar triangles.
Oh, yeah, I think I remember that now.
Yeah, there you go.
My brain's still trying to remember all the way back to the beginning of the semester. It's like, think, what did you do?
Yes, and it all gets jumbled because it builds on each other. Like even with those like octagons and stuff, we were still going back to triangles. So
Yeah, and I think a lot of times too, I'll overthink it because I'm looking back at like the simpler problems that we started with, and I'm like, but I feel like there's more. I could be adding a million other things to this.
well, on the exam, there's a mix. There's some that you have to think a little more. There's some that you will just know it right away. So I tried to give a good balance.
That's good.
Yeah.
And then 56, that's where I use 56 exactly. I'd be using the tangent, but that's like the tan with the -1, right?
Correct.
You're trying to find the angle, not the side.
So you just, since I have the screen up for that one, it is tangent because you're finding angle D. So it'd be like the tangent -1 for D equals opposite over adjacent, 11.2 over 8.7. That's how it would be set up. But then the calculator solves everything for you. You just hit the second button, so second tangent, and then this parentheses pops up, and you do 11.2 divided by 8.7. So you have to figure out which trig function to use. But once you figure that out, it's just punching in the calculator.
That was simpler than I thought it was.
Good. And I'll just give you a hint. I saw a peek at the Algebra 2 exam, and they have these kind of problems on the Algebra 2 exam. So you'll use it next year also.
Okay, good to know. The one thing I can't forget how to do then.
There you go.
I somehow am noticing though that like I'll forget it, but then someone will mention what I'm supposed to do, and then I'm like, I actually do know what I'm doing. And then 59 and like 60. solve the right triangle is you find all the angles and all the side measures, right?
Correct. Whatever's missing, you fill in the missing pieces. Let me, D9, you said?
Yeah.
So in 59, that little degree symbol got weird at the bottom there, but you would need to find angle C. How much is that angle? And you need to find side BC and side AB. Those are the three things that are missing.
Okay. Oh, that makes sense. So then I'd find angle C, and then I could do like tangent or something. What would that be? That'd be sine. And then I could find y using Pythagorean.
Yeah, these ones are a little bit like proofs in that different people will see different orders to find them. Like some people might find angle C first, or some people might jump to the trig functions and go ahead and find x or y first. It doesn't matter really. So when I check them, sometimes people's decimals are off a little bit because it depends. Like you said, you were going to use Pythagorean, where somebody might use trig to find both x and y. So it just depends on how you approach it.
Okay. I've always wondered that too, because I'll get different answers when I solve it with like it's slightly different. It's not completely different, but if I use Pythagorean compared to like trigonometry, then I'll get like slightly different answers. And I've always wondered why that was, because I was like, it should be the same answer, shouldn't it?
Yeah, it should be really close. It's all about rounding. Your calculator, I mean, at some point, it's limited on how many decimals it can hold in your functions when you're punching them in. Or if, let's say that, let's see, um, let's say that you got x's. I'm just going to make up a number. You got the x's 5.37984, blah, 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 but you rounded it to 5.4. And then you use that to find y. So that rounding would change your y, stuff like that.
Oh, okay.
Other questions?
61.
Okay.
I think I kind of remember how to do it, but not really.
All right. And hopefully your sheet is not cut off. One of the copies I have here is cut off a little bit. Yeah, yours has it. Good. All right. Let me. All right. So you begin at the trailhead about at 7,500 feet. It ends near the summit, elevation 2.5 miles. The horizontal distance between these is 18,200. Estimate the angle of elevation from the trailhead to the summit. So the angle of elevation, if you're at the trailhead and you looked straight, that's the bottom of your angle. But for elevation, you're looking up. So they want to know this angle. When you're standing at the trailhead and you're looking up at the summit, what's that angle?
Okay, so then. So would I like what's the word for it? Convert the 2.5 miles to feet
Yeah.
and find the difference between the height of the summit and the height of the trailhead to get that one.
To get this side right here. Yes.
And then I could do tangent to find that angle,
Correct.
the second tangent thing. Okay.
Yep. If you want to try it, I can tell you if you get there, if you want to check on it.
Oh,
If you
yeah.
got it right. Okay.
And then miles, a mile is 5,280 feet, correct?
Yes. Is this how you've set it up so far?
Yeah.
Good. So what did you get for that angle of elevation?
I got 17.4.
You are correct. Very good.
Yeah. Okay. Now I know that I know how to do this ones.
There you go.
That's one more question that I know I'll get right.
That's a good way to see it.
And then I think the last question I had was number 69.
Okay. Let me get that one. Oh, okay. All right, one interior angle of a parallelogram is 42, more than twice another angle. Find the measure of each. So because there's not a picture, I always draw a picture. Not a great picture, but a picture. Do you have a minute? No. All right, hang on one second, Alex, okay?
Okay.
All right, sorry, Alex. You there?
Yep.
Okay, sorry about that. All right, so there's not a picture, so I drew a parallelogram, and it says that, well, first of all, in a parallelogram, remember that opposite angles are congruent, and consecutive angles, like the two that touch the top of the parallelogram, how are they related, these two?
They're supplementary.
Yes. So remembering those facts about the angles in a parallelogram is the key to doing this one. So one measure is 42 more than twice the measure of another. How do you write 42 more than twice?
42 plus 2x.
Mm-hmm.
Using x as a variable.
There you go. So I'm just going to make this angle over here, that measurement, 42 more than 2x. That x represents the measure of another angle. So the only other angle in this parallelogram that we don't know about would be this one, right?
Yeah.
Or this one, whichever, because both of these are the 42 plus 2x. That makes sense?
Yeah.
All right. So 2 ways to approach it. Different people that were asking saw it different. A few people said, oh, well, we add up all 4 of those and they should equal 360. And that's right, because it's a quadrilateral. But so that there aren't as many pieces in your equation, just the top 2 should add up to 180.
So I do 42 plus 2x plus x equals 180.
Exactly.
And then solve for x.
Yes.
So would x equal 46?
It would. Very good. And it says find the measure of each angle. So x would be 46. Oh. So that's this angle. And then how would you get the other angle?
You just plug in 46 for the x. So
That's right.
42 plus 2 times 46.
Yeah. We woke up Zoe Cruz. It was not nice. You made her cry. You woke her up.
Uh-oh.
Sorry.
It's all right. And then the other angle would be 134.
That is correct.
Oh, I just realized you could do 180 minus 46 to get that too.
Yeah, either one is fine. Number 70 is the same. It's just different numbers to set up your variable equation.
Okay. And then for 67, I just wanted to clarify that. I think that one's where all the interior angles add up to 360.
For 68, all exterior angles add up to 360. But interior angles, you use that n minus 2 times 180. Do you remember that? Kinda, a little bit.
Oh, yeah.
That is, let's see, I'm trying to find where it is in the book. It is on 501 in the first section of chapter 8. Polygon interior angles theorem. So got blurry, sorry. So this one has 5 sides. So the n would be 5.
And then, so that's 3. So all those angles add together to equal 540?
That's correct. So first you get the total, and then you take all those pieces and set up an equation where all of them together equal that total.
Oh, I remember that now.
Good.
You had to add up all the numbers, and it was like this giant number that you'd get, and then you had to do all the solving for x.
You are correct. Yes.
Okay, I'm glad I clarified that then, or else I would have gotten it wrong.
Yes, the exterior angles, that's in that same section, 8.1. There's a theorem for that. But no matter how many sides the shape has, the exteriors always add up to 360.
Okay, I remember that now.
And on 68, that 22x plus 1, on my paper, it kind of looks like divided by 1, but it's not. It's plus.
Okay, it did kind of look like divided by.
Yeah. I try not to use this symbol on any of the things. So if it looks like that, it's probably addition.
Okay, yeah.
Doesn't
that too, where it'll look like it's a division sign, and I'm like, but did we ever actually use that division sign at all?
I don't think so. I can't think of a problem where that was in it this year, but it always kind of looks like that.
Yeah, because it kind of fades out.
Yes. Other questions?
I think that's it for right now.
Okay. Well, I'll still be signed in for another half an hour. So if you're looking over it and you think of something else, I will be here to help.
Okay. Do you think later today maybe you could put out like the answer key for this so I can check my answers?
Yes, I had a scanned copy and in my files I didn't see it, so I'm gonna have to like take pictures of my sad looking copy and then I'll send it out.
Thank you, because that way I can make sure I got it all right too.
No problem.
Thank you so much for all your help.
You're very welcome. I'll be here if you have more questions.
Okay, thank you.
You're welcome.
Bye.